Hi everyone, today I'm going to be doing an AP Calculus AP exam free response question of 2004 and I'll be doing number 6. And this problem is considering the differential equation dy over dx equals x squared times y minus 1. We're going to start with part A, which asks, on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. And so first you have to realize that dy over dx indicates slope, which we're going to indicate by the letter m. And so first we want to look at the easy slopes like 0, just to get them out of the way and give us a nice structure to start with. And so we know that the slope will equal 0 when either x squared equals 0 or y minus 1 equals 0. And we know this because anything multiplied by 0 will equal 0. So if this x squared is 0, the whole thing will be 0, or if this y minus 1 is 0, the whole thing will also be 0. So we manipulate these equations just a little bit to get x equals 0 and y equals 1. So we know the slopes will be 0 along the lines x equals 0 and y equals 1. So we're going to draw in those 0 slopes. And a 0 slope can be indicated by a horizontal line. So I'm just going to draw those in. So I drew those in along y equals 1 and x equals 0. And now we're going to look at the more complicated points. So we're going to start with negative 1 comma 0. So we're going to plug those coordinates right into this differential equation to get what the slope will be. So we get m equals negative 1 squared times 0 minus 1, which equals 1 times negative 1, which equals a negative 1 slope. So we're just going to draw that in. Now we're going to start at our next coordinate, 1 comma 0, and we're going to do the exact same thing. We know that the slope will equal 1 squared times 0 minus 1, which equals 1 times negative 1, which indicates a negative 1 slope. Now our next coordinate, negative 1 comma 3, we're going to do the exact same thing and put those coordinates right into that slope equation. And we get negative 1 squared times 3 minus 1 equals 1 times 2, which indicates a positive 2 slope. And we're going to draw that in. And then we're going to do the exact same thing again with our coordinates 1 comma 3. Plug those coordinates into that slope equation. We're going to get 1 squared times 3 minus 1 equals 1 times 2, which equals a positive 2 slope. Now we're going to do the same procedure again with negative 1 comma 2. Plug those coordinates into that equation. We're going to get negative 1 squared times 2 minus 1 equals 1 times 1, which indicates a positive 1 slope. And for our last point, we're going to do the exact same thing. Plug those coordinates into that slope equation one last time. We're going to get 1 squared times 2 minus 1 equals 1 times 1, which indicates a positive 1 slope. And there you go, ladies and gentlemen. There's our slope field. Now we're going to move right along to part B that asks, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. Now we're going to start this problem by realizing that the slopes will be positive when this whole thing is greater than 0, or positive. And we also have to realize that there are two cases in which this could be right. And it could be when x squared is positive and y minus 1 is positive, because a positive times a positive will equal a positive, or when x squared is negative and y minus 1 is negative, because a negative times a negative will also be a positive. And so we can also look at these two cases, which is our positive case and our negative case. And in our positive case, x squared is greater than 0 and y minus 1 is greater than 0. Or we can look at our negative case, which is when x squared is less than 0 and y minus 1 is less than 0. However, if we look at our negative case and we look at this x squared is less than 0, we realize that x squared can never be less than 0, because any number to the second power will always result in a positive number. So we can completely disregard this second case and just look at our first case. Now if we look at our first case, we can manipulate these equations just a little bit to get when x is greater than 0 or x is less than 0, and when y is greater than 1, the slopes will be positive. Therefore, we can write in our conclusion that slopes are positive where x does not equal 0 and where y is greater than 1. Now we can check our conclusion by looking back at our part A and seeing that when y is greater than 1 and when x does not equal 0, if these last 4 points have a positive slope. And we can check them, and we can see, yes, they are positive, which leads us to believe that our conclusion is correct, which is always nice. Now we're going to move along to our last part, part C, And part C asks, find the particular solution y equals f of x to the given differential equation with the initial condition f of 0 equals 3. Now, f of 0 equals 3 can also be written as 0, 3. And we're going to look at our differential equation, dy over d of x equals x squared times y minus 1. Now, what we're going to try to do is we're going to try to get back to our original equation and get y equals f of x. And to do this, we're going to use separation of variables. So first, we're going to try to get y's on the left-hand side and x's on the right-hand side. And to do this, we're going to multiply both sides by d of x. And when we do that, we get d of y equals x squared times d of x times y minus 1. And then we want to divide both sides by y minus 1 to get those y's on the left-hand side. And we can also do that by multiplying each side by 1 over y minus 1. And when we do that, we get dy over y minus 1 equals x squared times d of x. And then we want to integrate both of these sides. And when we do that, we get natural log of y minus 1 equals x cubed over 3 plus c. And when we integrate this x squared, we're going to use the power rule. And the power rule states that you add 1 to the exponent and then divide by that new exponent. So we get 2 plus 1, which gives us that new exponent of 3, and then we're going to divide by that new exponent of 3 to give us that x cubed over 3. And then we always have to remember to add that constant of plus c when integrating. And then we're going to take both sides, we're going to do e to the power of both sides, and then that'll give us this. And then we're going to be able to cancel out that e in natural log, which was the whole purpose of using that e. And then that's going to give us y minus 1 equals e to the x cubed over 3 times e to the c. And now this e to the c is a constant, which means that we can bring that c up to the front of that e to the x cubed over 3. And then when we do that, we get y minus 1 equals c times e to the x cubed over 3. And now we want to find what our c value is. And because we're given that initial condition of f of 0 equals 3, which is also written as 0, 3, we can plug those coordinates right into this equation right here. And when we do that, we get 3 minus 1 equals c times e to the 0 power. And we know e to the 0 power is 1, and 3 minus 1 is 2. So then we end up getting c equals 2. Now we're going to put that c value right back into this equation. And we get y minus 1 equals 2 times e to the x cubed over 3. And then we want to get that 1 to the right-hand side, so we can get, this y equals f of x. And when we do that, we end up with our answer, y equals 2 times e to the x cubed over 3 plus 1. Thank you all for watching. Other slope field/differential equation for your response questions for reference include the 2004-2008 AP Calculus AP FRQs, and are listed in front of you. And these and other prior free response questions can be found at apcentral.collegeboard.com. And I also found a reference video about intro to differential equations and slope fields from Khan Academy. That is very helpful if you're still confused about slope fields. And the links to both those will be in the description below for convenience. I hope you all have a great day, and bye!